All right. Page 15, all right? So this one, in a sense, guys, this form is not new to us. We've seen it already. I'm just going to highlight a few things that it gives us right off the bat, right? Just by looking at it. So there are three forms of the quadratic. The general has no brackets, right? The general has no brackets and looks like that. We've seen that a lot. But now we're talking about the vertex form, okay? So how do you know it's in vertex form? When you have brackets like this, okay? You have a set of brackets there, and then a number just tagging along like that. So basically, you just have one set of brackets. And it provides you with this. It provides you with the direction of opening. All of them do that, by the way. What the width is going to be. And it gives us the number of x-intercepts and what the vertex is going to be. This is going to be the most important part out of it. Like, it tells you what the vertex is. That's the most important piece of information about this particular form. So in general, it looks like this. Watch, it's H and K, right? Those are the letters we use, where A is telling us still direction of opening, right? Is it positive or is it negative? And it's still going to tell us what the width is, okay? That doesn't change. Once you, bigger than 1, narrow, between 0 and 1, it's wide. But here's the important piece, and when you have this on your study sheet like this, I want you to have the vertex. You're going to read it off of that, and watch this. K stays the same. Whatever K is, whatever that number is, you plug it in there. But the H, this value changes sign when it comes out. Okay? So that is important. I'll make a little note there. Changes the sign, okay? So when you take it out and you want to actually state your vertex, it'll be with a different H sign, okay? So here we go. We've got 3 different scenarios here. I'm not going to do all of them. I'm just going to do maybe one and then let you do the rest. So direction of opening, this is going to be down, because A is negative, right? A is right there. That's A. It's negative, so we know it's pointing down. What is the width? This is going to be a normal, because A is equal to 1, right? It's just 1. The vertex, here it is. So you can tell that this is in vertex form, and that would be -4, and the 5 stays, positive 5 stays. Okay? So that's basically the main concept today. Is like, if you notice it's in vertex form, then you can easily tell what the vertex is. And let's say you miss it, type it into your calculator and find out. I would say that's the hard way of doing it, but it's still there. What is the y-intercept? It's not 5, correct? Because it's not in general form. So I'm going to just suggest you use this. Second trace value, x is equal to 0. So in a sense, so you don't have to do this, but negative x plus 4, the most common mistake is students forget to square this. Okay, you got to make sure you square it, and then it's plus 5. So we knew it's pointing down, and the vertex is there, which makes sense, right? -4, 5, it makes sense. But the y-intercept is here somewhere, so we're going to go second trace value, right? And then x is equal to 0, and it is -11. Okay, so we have it 0, -11, -11. Okay. Can you do that by hand? I think I've shown you that already. I will show you one more time. Okay, I will do this algebraically, because from time to time I will ask you to do that by hand. Okay, so what you do is you let x equal to 0. So you just plug in a 0 where there's an x, okay? I'm just going to say this, let x equal to 0, because these are your notes, right? You want to go back and see what happened there. And then just slowly work this out. This is going to be 4, correct? 4 squared is 16 plus 5. This in turn is just negative 16 plus 5, which is negative 11, correct? So you found when x is equal to 0, y is equal to negative 11. That's what you found there. So you always have the calculator there to verify what you just done. Okay. And the common error here is students think that the constant k is the y-intercept, but it is not the y-intercept. Okay. So make sure you understand. I'm going to leave it like that for now. So can I ask you to, for homework, so there's not going to be a whole lot of homework. I'm just going to ask you to try these ones here. So homework, I'm going to keep going a little bit. But these two, I'm going to leave them up to you to try, okay? And I will post the answer key. It shouldn't take you like minutes. We're talking 1 or 2 minutes here. And maybe practice doing the algebraic method just to verify. Use your calculator, and then you can also use your calculator to crunch this, right? I just need you to show me the lines that result from it. Let's go to 16 here. Okay, another cool thing is about the vertex form is it tells us, I'll just put that heading here, tells us the number of x-intercepts. Okay? It doesn't tell us what they are, like the coordinates. It just tells us how many we're expecting. So if A and K have the same sign, what is A and K again? Let's quickly, I'm just going to show you. A is the leading coefficient, right? K is the back number. So if you look at those and they have the same sign, there will be no x-intercepts. Okay. How is that? Well, if K is positive, listen carefully here. If K is positive, it means that the vertex is above the x-axis, right? So it's going to be somewhere here, and it's going to be pointing up. So in this case, x positive K, so K is positive, and A is positive. So they both have the same sign. It's never going to cross the x-axis. So again, it has to do with A and K. A is positive, sorry. If K is negative, then that means that the vertex is somewhere below the x-axis. And if A is negative, it's pointing down. So A is negative, and K will also be negative. So if they have the same sign, you can bet that there's not going to be an x-intercept. It's just not going to happen. Okay? If they have opposite signs, if A and K have opposite signs, we will have 2 x-intercepts. The most common case. How so? Well, let's say K is positive, then that means the vertex is somewhere up here. So we're going to go K is positive. And if A is negative, right? If they have the opposite sign, then it's going to have 2 x-intercepts. Similarly, if K is negative, right? K meaning the y value of the vertex. That's what K is in this case. And A is positive, it's going to cross it twice here. Okay. And so they have the opposite sign. And if K is equal to 0, sign doesn't matter. You're going to have one x-intercept. I'm just going to give you a quick example, because this one is maybe, so let's say you have negative 2x plus 3 squared. Can you tell that k is 0 here? It's right here where my pencil is hovering, technically, right? But it's not there, so k is equal to 0. K is equal to 0 right there. So that means that you're right on the x-axis. So you could be here, or you could be right on here. So the vertex, so how about this? I'll just tell you, it's going to be x0. It's going to be x0, right? It doesn't matter. You might be somewhere on the x-axis, though, nevertheless. So that's how you know, by looking at this one, you can tell right away how many x-intercepts there are. Okay. So tell me, if you look at this one, you should recognize this is in vertex form. How many x-intercept would you expect this thing to have? A is negative. K is negative. Who said 0? Did you say 0? 0. None. No x-intercepts. This one? 2. Okay. So you make reference that A is negative and K, sorry, positive. I know math every once in a while. A is positive, K is negative. So there's going to be an opposite effect, right? So 2 x-intercepts. Calculate the y-intercept algebraically. I'm going to leave that up to you as well. Homework, so put homework there. We're getting there. I want to get to the graphing part. I'm just going to tell you what I want you to try to graph. So graphing is going to be very important in this unit. Backside, write an equation that satisfies the following conditions. It's narrow. What do we know? A is going to be greater than 1. It gives us the vertex. If I give you the vertex, which form should you be using? Vertex form, right? Also known as descriptive form in some textbooks, but I call it the vertex form. So, okay, vertex form, 2 x-intercepts, and obviously it does tell you vertex form, but just in case you didn't know. So I'm going to start this up. I'm going to go y is equal to, if it's narrow, something bigger than 1. So something slightly bigger than 1, okay? There you go. That'll do it. And then it's x. I have given the vertex, correct? If I take that, that's h. What will it be in here? Positive 2, that's right. And I'm going to square it. And I'm going to go plus 4, correct? This k value does not change. Okay? The k doesn't change. It stays the same. Only this sign changes. So change sign. Sign changes. That's very small, eh? But you can see it. Okay. Are we good there? Right now, as it stands, how many x-intercepts would this thing have? Positive, positive. If they're the same, there's no x-intercept. So what do we need to do? We need to change the sign here to negative. Got it? Make a negative so that we have 2 x-intercepts. Do last, okay? You take care of this sign last. You first make sure you plug in the values as given to us by the vertex, and then you change the sign if it's needed, okay, if required. I'm going to also leave these ones to you. Okay. So if you, if you spend the time, it shouldn't take you all that long. Make sure you try them. Okay. You need to think about it. Here is a graph. What do we need for graphs again? Vertex, intercepts, right? Same thing, it never changes. Do I need to use my calculator to find the vertex here? Let's say it's like Monday morning, you forgot about it. You type this into your calculator, you find the vertex, and all of a sudden you're going to realize, oh, what's the vertex, by the way? +1, -9. Okay? You know the vertex is there. Okay? Because you know this is in vertex form. What is the y-intercept? 0, -9. Nope, it's not, right? It is. We got to use our calculator for it. Maybe I'll do this with you. Oh, I shouldn't have erased it, but anyways. X minus 1 squared, take away 9. Let's graph it. Hey, perfect. It actually showed up. So I'm going to find the y-intercept, second trace 1, x is equal to 0, and there it is. It's -7. When you're graphing, I don't want you to do anything algebraically. Okay, I don't want you to spend that time. Use your calculator. I'm just going to go second trace 1, x is equal to 0. That's what I used there. X-intercepts. There's 2. Could we have predicted the 2 x-intercepts? A and K are opposite signs. Yes, okay. So I'm going to find the x-intercepts. Second trace 5. I'm going to find that one. That is -1.120. Do it one more time. Second trace 5. Travel over to the other side. Enter, enter, enter. That is 3.12. 3.120. What did I use? I went y2 is equal to 0. Second trace. It can look like a doctor's note. Okay, I'm not too picky with that. But make sure you tell me you use the calculator there. This one you just read. Okay, I just read that off the equation. If you use your calculator, no problem, just tell me. Okay? Most of the time, it will be just like that. You put arrowheads, you label. Where does your vertex go? 1, -9. So 1, this is already scaled up, so you're welcome. 1, -9 is here. 0, -7. 0, -7 is here. -1.12 is right about there. 3.12 is right there. You've got everything you need to graph this. Nothing really changes all that much. There we go. And just write down x minus 1 squared minus 9. There you go. There's your graph. So what I would like you to spend most of your time on is found on page 18. There are 2 graphs there. So make sure. Did I go too fast? Sorry. Here. Stop rushing. Got a little bit of time. 2 minutes. So I'm just going to say homework, page 18. Plus, fill in, right? Fill in pages 15 to 16, basically. Make sure you try those graphs. They're right next door. Read carefully what I'm asking you for. And then graph.